Da-na-na-na. 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 Welcome to the Tectonic Talk Show. I am your host, Mrs. LaRue.
And Mrs. Diamond.
Woo! Okay, today we have two beautiful and lovely guests that would like to learn more about plate tectonics. Plate tectonics move real slow. Our first guest, she comes to us from second grade at St. Genevieve Elementary. Let's welcome Brooklyn Giesler! And our second very own guest, she claims that she didn't learn anything in my class and she knew it all, and she's in 8th grade. Let's bring it up for Vela Lytle.
Vela! Clap yourself, Vela. I'm Vela.
So we're going to learn about how plate tectonics affect the shape. I like my circles a lot. How they affect the shape of our Earth.
All right, so we're first going to just review the layers of the Earth. So we know the crust is the outermost layer of the Earth. And as we go inward, we have the mantle, the outer core, and the inner core. But you guys are awesome. You already know about that. So let's just review real quick. The lithosphere is the crust and the uppermost part of the mantle. So that's our rocky layer. That really is what makes up our plate tectonics, or our tectonic plates. And then just under that we have the asthenosphere. And our asthenosphere is where our convection currents are located. So what happens is, remember, it's semi-liquid, so it's kind of like that toothpaste consistency. And what happens is, as the materials, the molten materials, go further into the geosphere, then it will start to heat up, because further into the geosphere, the more heat you get. And so as it heats up, it becomes less dense, right, Vela?
Yes.
Yes, less dense. And what happens, Vela, when it becomes less dense?
Yeah, what does happen, Vela?
It rises, Miss Diamond.
It rises. So it starts to rise to the surface, and then once it rises to the surface, it starts to cool off a little bit. And once it cools down, it becomes more dense and causes a fall. And when that happens, that sinking force is what drives the movement of the tectonic plates.
Okay, so now that you guys know the force, let's check out and see what that force has done. Okay, so this is a beautiful map. So basically there's 7 main tectonic plates, and then there's many others. As you guys can look here at the map, it's really cool because you can see the direction that the plates move. Okay, so for example here, let's go ahead and take a look. I like red today. All right, so if you can see the South American plate, it is moving this direction. The Nazca plate is moving this direction, all right? And this is creating a plate boundary, all right? And as you can see what direction these plates are moving on this map, okay?
This is actually
now,
really cool.
I know
It's
it
so
is.
awesome, isn't
Thank you,
it?
Miss LaRue, for teaching us.
Okay, but wait, there's more. Okay, so if you look here, we actually can see the directions, and all these lines right here are the cracks in the eggshell that I talked to you guys about on our crust, okay? And these cracks is part of the lithosphere, known as tectonic plates.
Miss
Hey,
LaRue,
Miss Lor. Oh, what?
Oh.
You said the wrong form of grammar there.
Oh.
What?
You said the plate says something instead of are something.
Okay, this is my English class, go away. Okay, so.
Miss LaRue, did you hear about Turkey Day?
Turkey Day, what happened on Turkey Day?
Oh my gosh, there was a 7.0 magnitude
I don't
earthquake
think I've ever even heard
What?
of that.
Holy
on
cow.
Turkey Day.
Where was it at? Oh, do tell. Do
El
tell.
Salvador.
That's
What?
kind
That's
of
like
cool.
in Central America.
Oh my, is that like north or south of us?
That's south.
I hope we're not close to it.
South America. Got it. Okay, South America. Okay, got it. Oh my gosh. Okay.
Oh man, that was crazy. That
Oh
was
my
crazy.
gosh.
On
Did you guys?
Turkey Day. of
Oh,
all-
Turkey Day. You think I bet their turkey was shaking bacon.
It's
Okay.
like shaking, Marco.
Here we go. So
So the divergent boundary is the first type of boundary of the 5 that we're going to talk about. So a divergent boundary is where divergent means spread apart or move apart. And so the divergent boundary is when a plate moves apart due to the force of tension. And so, bring it to Miss LaRue.
Miss
All
Laura,
right.
please tell us some more about this.
Okay, why sure, little Brooklyn, who's in second grade that knows everything. Now, the plate move apart due to the force of tension, as Mrs. Diamond did point out. And some rocks are stronger than others, and you guys learned about that in the rock cycle. You guys know sedimentary rocks are a bunch of sissies.
Weak.
Yeah, weak. Check out the way the process we go through. But igneous and metamorphic, they're tough stuff. I mean, look at what they had to go through, okay? So they're pretty strong. All right, so if you guys look here, this is the picture underneath the ocean. Check it out, oceanic crust. And this is water. Okay, and what's happening, if you look at the arrows, is dividing, divergent, divide. Get it? Good. And as these plates are moving apart, it allows this magma to rise. Because there's an opening there, and this magma's like, help me, get me out of the asthenosphere. So this is a crack, and it allows to come up here, and then it creates brand spanking new crust.
Whoa, brand new?
Yeah, brand new. So this is the newest. And Vela, what do you think it happens whenever we get further away from there? Do you think the crust gets newer or it gets older?
I think it gets older, Miss LaRue.
That's right. So the farther away you get, the older the crust is.
That's
It's-
awesome.
I
Where
know.
is that, Miss LaRue?
Oh my gosh. Okay, so this is called the Mid-Atlantic Ridge, and this is located underneath the Atlantic Ocean, and it goes from pole to pole.
So that is crazy.
I know it's not.
That's a very, very long ridge.
That is. That's a big crack. Okay, now if you look here, here's a beautiful picture of it close up. It's kind of like, I think Brooklyn, she designed this for us. I thought she did a beautiful job. This is actually the mid-oceanic ridge on a divergent boundary, okay? All right, so thanks to our lovely guest, Brooklyn.
Thanks, Brooklyn.
She drew this picture, and look at her convection currents, okay? So she knew that they went away, her beautiful water there. So there's a nice little visual for you.
Yeah, the mid-oceanic ridge.
Okay, well, folks, say goodbye to Brooklyn. She has to go now. Bye-bye.
Bye,
Goodbye.
Brooklyn.
Bye. Have a play tectonic day. Okay, now
All right.
here's another aspect of this. Okay, is a fault block mountains on a divergent boundary. Now this is actually on continental crust. Okay, now with the force of being stretched, tension, the weaker rock will actually start to break down. Okay, and it creates this really gorgeous mountain range.
That
Okay?
is pretty. That is pretty.
I think it's pretty neat if you ask me, Mrs. Diamond.
That's right.
It's pretty neat.
We love those strong and weak rocks.
Yeah, we do. So here we go. You see it? So which is the weaker
Oh,
link?
wow.
See? And there you go. That is our beautiful divergent
Boundary.
I know.
Hey, where's this at, Miss LaRue? I want to go here.
Actually, it is located in Africa. Great Rift Valley in
wow,
Africa.
The Great Rift Valley.
It's in the
Africa.
northeast section. It's actually located next to Egypt. Walk like an Egyptian.
All right, then we have the continental convergent boundary. Is this number 2? This is number 2.
Woo!
All right, so continental convergent boundary is where convergent means coming together. So it's when two
together.
plates are coming together and there's a force created and it's called compression. That force is compression, and it causes the rocks to fold as a result of pressure and heat as the hot rocks are colliding. So this is where mountains grow due to uplift. So we are exposing those metamorphic and igneous rocks underground. And, oh, look at that. And they can reach the Earth's surface to start going through weathering and erosion.
So that's how we know what's inside the earth.
And that is another cool picture.
That is another cool picture.
And that's
Brooklyn.
another. Okay, now here's a great example of a continental convergent boundary. This you guys can see. You see the continent? That's continental crust. Continental crust. And guess what? The mother of all mountain ranges is created because of these two plates coming together called the Himalayan mountains.
Yeah.
Peru, is that where Mount Everest is?
That is correct. Do you know it's the tallest point in the world?
Really?
Yeah. But the crazy thing is, the most erosion and weathering that ever occurred on Earth is occurring right now as I'm talking to you in the Himalayan mountains because
Wow,
it is so
that's
tall.
amazing.
And that's why it won't reach Mars. Always get that question.
All right, so then we have the continental oceanic convergent boundary. So we have our continental, we have our land boundary or plate, and then we have our oceanic plate coming together. And so the oceanic plate is made mostly of igneous rock, and because of that, it is a lot denser, and so it sinks and it goes underneath the less dense plate, the continental plate. And so when that happens, it creates the force of compression, and the oceanic plate is melted into magma in the mantle, and it creates volcanic mountains on land.
Let's check some out. All right, so if you guys look at this visual, okay, over here on the left, we have continental crust. Over here on the right, we have oceanic crust, okay? So as Mrs. Diamond just pointed out, because it is denser, it's going to subduct, okay? Now, the crazy thing about this one is, boys and girls, is the fact that it melts back into the magma, okay? It goes back into magma right here. Well, guess what? In the asthenosphere, they're like, hey, look here, old man. We're not going to recycle you. There's not enough room. You have got to go. So what happens? Well, he's melting back into magma. It's already full down here. So what happens is it actually will find the path of least resistance, like some of you guys do in assignments, and it will reach up to the Earth's surface, okay? And it forms this big chamber of magma. It hangs out here for a while, but then when it builds up pressure, boom! And that's where volcanoes are located.
Awesome. Okay, so the oceanic and oceanic convergent boundary is two ocean plates coming together. And so since they are both dense plate, basically the less of the two, denser, will come together through, again, that force of compression, and again causing, instead of volcanoes on land, it will form islands. It will create volcanic islands like Hawaii. I want to go there right now.
And like Japan.
Oh yeah, Japan.
Okay, so if you guys look here, all right, so we have the island arc here. All right, this is where the islands form, and it's the same scenario, okay? It gets recycled. They're down here in the asthenosphere. They're like, dude, you're not staying here. You got to go. So they find the path of least resistance, and then the melted rock magma reaches the Earth's surface. All right, guys, we're almost there. Okay, the last one is the transform boundary, okay? Transform boundary, if you guys look here, we have one, it slides up, the other one slides down, okay? And these actually create what is called a shearing effect, a shearing force. It goes shh, 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 okay? A great example here is called San Andreas Fault in California.
Is this the fifth boundary, Miss LaRue?
It was a fifth one. Did I not
Awesome.
label
So
it?
we have all five. Nope, but that's all good.
Okay,
This
so
is
that
the
was,
fifth
okay,
one.
good job. So that just
All
means
right.
they have to listen.
Yep.
Okay, so here's a great picture for you guys to look at. Tension is when they're actually moving away from each other, like some of you guys right now are under a lot of tension and stress. And this is what we call a normal fault. Compression, when the plates come together. That is what is called a reverse fault. And then the last thing I want to point out to you guys is the transform boundary, and this is what we call a strike slip fault. So what is due tomorrow, Mrs. Diamond?
All right, guys, explain and draw the 5 plate boundaries that we talked about in this video. Make sure you were listening and go back if you have questions.